Welcome to Engineering Out Loud. This is the third in our series from MECHESOL's MESP Engineering Development Program.
Sounds great.
And we are going to dive deep into materials and manufacturing processes today.
Oh, that's cool. I like materials.
Yeah, if you are ready to explore the amazing world of materials that shape our world, buckle up and get ready for the ride. And if this sparks your engineering passion, be sure to check out more of the MESP Engineering Development Program. You can visit mechesolco.com/CPD.
Awesome. Let's get to it.
All right, so we're surrounded by things made in factories. But have you ever stopped to think about, what they're made of and why that even matters?
It's a good point. We often take the materials around us for granted.
Right.
But yeah, they play a critical role in the design and the function and the durability of everything we use.
Absolutely. So I've got our materials expert here to help us break all that down.
Yeah.
What are some of the most common materials that are used in manufacturing?
Well, we can group them into a few key categories like metals, wood, and wood composites, glass and ceramics, and of course plastics. Those are everywhere.
Okay, that's a lot to unpack. Let's start with metals. I know steel is everywhere.
Yeah.
What makes it so popular for making things?
Think of steel as the reliable workhorse of the manufacturing world.
Okay.
It's strong, it's relatively affordable, and you can shape it pretty easily into various forms. Plus, steel comes in a huge variety of grades with different properties, so it's super versatile.
So it's not a one-size-fits-all kind of material.
Not at all, no. You wouldn't use the same type of steel to build a skyscraper as you would to make a delicate surgical instrument, right?
Right. Can you give us a few real-world examples of how different types of steel are used?
Sure, absolutely. Take stainless steel, for example.
Okay.
It's famous for its resistance to rust and corrosion, which is why you see it in things like cutlery, surgical instruments, even watches.
Yeah, that makes sense.
On the other hand, carbon steel is prized for its strength and how easily it can be formed. So it's perfect for things like nails, screws, stuff like that.
Wow. So the kind of steel really does dictate how it's used.
Yeah.
Now, what about another metal we see a lot of, like aluminum? What are its strengths?
Aluminum is the champ when it comes to being lightweight.
Okay.
It has a fantastic strength-to-weight ratio.
So that means it's strong but not heavy.
Exactly.
Okay.
And it's also highly resistant to corrosion, making it ideal for things that are used outdoors.
It's like those lightweight bicycle frames. I love those.
Yeah, exactly. And you'll also find aluminum in everyday things like soda cans and even parts of airplanes.
It's amazing how these metals are all around us.
Yeah.
Now, I'm curious about some of the less common metals like titanium and nickel. Where do they fit in?
Those are kind of like the high-performance stars. Titanium is incredibly strong for its weight, and it has exceptional resistance to corrosion. Did you know that a titanium hip replacement can last for over 20 years?
Wow, that's impressive.
Yeah, it's pretty wild. That's why it's used in demanding applications like aerospace components, medical devices, and even high-end sporting goods.
So when I see titanium on a product, I know it's going to be top-notch. What about nickel?
Nickel is known for its ability to withstand really high temperatures, and it's also super resistant to corrosion. You'll find nickel in everything from the coins in your pocket to smartphones, even jet engine parts. It's like a hidden hero of the material world.
Okay, that's fascinating. Now let's switch gears to wood and wood composites. I always get plywood, MDF, and OSB mixed up. Can you help me out with that?
Of course. So they're all made from wood, but they're engineered differently, which gives them some unique properties. Plywood, for instance, is made by layering thin sheets of wood veneer, and they alternate directions.
Okay.
This makes it strong, stable, and resistant to warping, which is why you find it in everything from furniture and cabinets to construction sheathing.
So that's why plywood is so good for building things.
Mhm.
What about MDF?
MDF, or medium density fiberboard, is made from wood fibers that are glued together under high pressure.
Okay.
This creates a smooth, consistent surface that's perfect for painting. That's why it's often used for furniture, cabinetry, decorative molding.
And OSB, what about that one?
OSB, or oriented strand board, is made from wood strands arranged in specific orientations, and then they're bonded together. This gives it strength and moisture resistance, so it's great for construction applications like flooring, wall sheathing, and roofing.
Okay, I think I'm finally getting it straight.
Mm-hmm.
Each type of wood composite definitely has its own strengths and best uses. Speaking of which, what about bamboo? It seems to be getting more and more popular as a sustainable material. And hey, if you're interested in learning more about sustainable materials and manufacturing processes, don't forget to check out MECHESOL's MESP Engineering Development Program. You can find more information and apply at mechesolco.com/CPD.
Bamboo is definitely having a moment. It's a fast-growing renewable resource that's incredibly versatile. You can find it in everything from cutting boards and flooring to furniture, even building materials.
It's amazing how something that grows so quickly can be so strong and durable.
It really is.
Yeah.
Now, if you are ready to delve into the world of more advanced materials, let's talk about composites.
Composites, those sound pretty high-tech.
They can be, yeah. Composites are basically materials made by combining two or more different materials to create something with superior properties.
It's like taking the best of both worlds.
Precisely. A classic example is fiber-reinforced polymers, or FRPs.
Okay.
These materials consist of a polymer matrix that's reinforced with fibers like glass, carbon, or aramid. The result is a lightweight yet incredibly strong material that's used in everything from aircraft and automobiles to wind turbine blades.
Wow, those are some serious applications. What other kinds of composites are there?
There are also metal matrix composites, or MMCs. These combine a metal matrix with a reinforcing material like ceramic particles, or fibers. This boosts their strength, stiffness, and temperature resistance, making them ideal for high-performance applications like brake rotors and jet engine parts.
Okay, that's pretty mind-blowing. Before we get too lost in the world of high-tech materials, let's bring it back down to earth a little bit. I think our listeners might be wondering how all these materials actually get used in the manufacturing processes.
That's a great point. Different manufacturing processes require different materials, and choosing the right material is crucial for success. Let's start with injection molding, which is a popular process for making plastic parts.
Okay, sounds good. I know plastics are everywhere, but I don't know much about how they're actually made into all these different products.
Yeah, it's a pretty cool process. So injection molding, it's kind of like using a giant syringe to inject melted plastic into a mold.
Okay, I can picture that. What kinds of plastics work best for this process?
Materials like polypropylene, polyethylene, and ABS are commonly used because they flow well when melted and can easily take on complex shapes. Think of all those intricate Lego pieces.
Yeah.
They are a great example of injection molding in action.
Oh, that makes sense.
Yeah.
So those are the go-to plastics for injection molding. What about blow molding? I know that's used for making like bottles and things like that.
Blow molding is similar, but instead of injecting plastic into a closed mold, we inject air to inflate a preform against the mold walls.
Okay.
It's how we create hollow plastic items like bottles, containers, and even some toys. You'll often see materials like polyethylene, polypropylene, and PET
Okay.
being used in this process because they can be heated and then stretched and blown into that desired shape.
So it's kind of like blowing up a balloon inside of a mold.
Exactly. That's a great way to visualize it.
Okay.
Now, compression molding is a bit different. It involves using heat and pressure to shape a material within a mold.
So it's more like squishing the material into shape.
You got it.
Yeah.
Thermosetting resins like phenolic resins, epoxy, and polyester are popular choices for compression molding. These materials can withstand high heat and pressure and solidify into really strong, rigid parts.
Okay, so we've got different materials for different molding techniques. That makes sense. But what about working with metals? How are they formed into different products?
Metalworking involves a whole range of techniques.
Yeah.
One common method is using press brakes. These machines are used to bend sheet metal into specific shapes.
So it's kind of like folding a piece of paper, but with metal.
Exactly. And just like you need the right kind of paper for different origami creations, we need specific types of metal that are easy to bend and shape.
Yeah.
Materials like mild steel, aluminum, and stainless steel are commonly used with press brakes.
I can see how that would work for making things like boxes or panels. What about creating rounded shapes or long metal parts?
That's where rolling comes in. It involves passing metal between rollers
Okay.
to reduce its thickness or change its shape.
So like flattening dough with a rolling pin?
Pretty much. Steel is the most common material for this process, but you'll also see aluminum and copper being rolled for specific applications. Think of things like pipes, tubes, even the sheets of metal used for car bodies. They all go through a rolling process.
Wow, that's amazing. What about forging? I've heard that term, but I'm not sure what it involves.
Forging is like shaping metal by hammering it. It's often done at high temperatures to make the metal more malleable. Steel alloys are the primary choice for forging because they offer a fantastic combination of strength, ductility, and heat resistance.
So it's for making really tough metal parts.
You got it. Think of things like engine crankshafts, gears, even tools. They are often forged for maximum strength and durability. Now, no discussion of manufacturing processes would be complete without talking about welding.
Right, welding is how we join pieces of metal together, right?
Exactly. It's the process of fusing two or more pieces of metal together by melting the materials at their edges. The choice of filler metal depends on the materials being joined and the desired properties of the weld.
So there's a whole science behind choosing the right filler metal for welding. It's not just melting things together randomly.
Absolutely. It's about creating a strong, seamless bonds between the metal pieces. And then there are soldering and brazing, which are similar to welding, but use lower temperatures.
So they're like gentler versions of welding.
You could say that, yeah. They're used to join smaller or more delicate parts, and the filler materials melt at a lower temperature. Solder alloys are typically based on tin and lead, while brazing filler metals come in a wider variety of compositions.
It seems like there's a lot of nuance to these joining processes. How do you know which one to use?
It all depends on the specific application and the materials involved. Sometimes a strong permanent bond like welding is needed, while other times a more delicate approach like soldering or brazing is better.
Okay, that makes sense. What about riveting? I know that's another way to join things together.
Riveting involves joining two or more pieces of material together using a rivet, which is a permanent mechanical fastener. It's like using a tiny metal bolt with a head on one end. The choice of rivet material depends on the materials being joined and the required strength of the joint.
So with all these different materials and processes, it seems like there's a lot to consider when designing and making a product.
Yep.
How do engineers keep track of it all?
That's where a deep understanding of materials science and manufacturing processes comes in.
Yeah.
Engineers need to carefully consider the properties of each material and how it will behave under different conditions. They need to choose the right materials and processes to achieve the desired outcome, whether it's strength, durability, flexibility, or even a specific aesthetic.
It sounds like a lot of responsibility.
It is, but it's also incredibly rewarding to see a product come to life and know that you played a role in its creation. If you are excited by the idea of designing and building things and working with all these amazing materials, be sure to check out MECHESOL's MESP Engineering Development Program. They offer fantastic training and resources for aspiring engineers. You can find out more and apply at mechesolco.com/CPD.
That's great advice. We've covered a lot of ground today. From the basic building blocks of materials to the complex processes used to shape them into the products we use every day, it's clear that materials are at the heart of everything we make.
Absolutely. And as technology continues to advance, we're only going to see more innovation in the world of materials. Who knows what amazing new materials we will be working with in the future?
That's a great thought. Speaking of the future, what do you think the future holds for materials in manufacturing? What are the materials that matter most to you?
That's a really personal question. For some people, it might be the materials that bring comfort and joy. Think of the soft cotton of your favorite t-shirt or the warm wood of a piece of furniture that's been passed down through your family.
Those are great examples. Materials can definitely have an emotional connection for us.
For others, it might be the materials that help them do the things they love, like the carbon fiber in a bicycle frame that helps a cyclist win a race, or the titanium in a surgical instrument that helps a doctor save a life.
I can see that. Materials can be tools that empower us. What about materials that help us build a better future?
That's a crucial consideration. Some people might value the materials that are helping to create a more sustainable future. Think of recycled plastics used in packaging or bio-based materials used in construction.
It's fascinating how materials can have such a profound impact on our lives in so many different ways. But how do we make sure we're using materials responsibly?
That's where the idea of a circular economy comes in. A circular economy aims to minimize waste and pollution by keeping materials in use for as long as possible.
So instead of a linear take, make, dispose model, we're talking about a more cyclical approach where materials are reused, repurposed, and recycled.
Exactly. It's about shifting our mindset from viewing materials as disposable to seeing them as valuable resources that can be used again and again.
It sounds like it would require a lot of changes, both in how we design things and in how we think about materials.
It does. A circular economy requires innovation in the design of product so they are more durable, repairable, and recyclable. It also requires advancements in the development of new materials and recycling technologies.
And this is where engineers have a crucial role to play, right?
Absolutely. Engineers are at the forefront of designing products that are made to last, that can be easily repaired, and that can be recycled efficiently at the end of their life. And engineers are also developing incredible new materials that are bio-based, biodegradable, or easily recyclable. It's a really exciting challenge.
It sounds like it. I'm inspired by the idea of using our engineering skills to create a more sustainable future.
It's definitely a field with a lot of potential for positive impact. If you're interested in being a part of this movement towards a more sustainable future, I encourage you to learn more about MECHESOL's MESP Engineering Development Program. They're training the next generation of engineers to tackle the world's biggest challenges, and sustainability is a core focus of their program.
That's great advice. You can find out more about the MESP Engineering Development Program and apply by visiting mechesolco.com/CPD. Well, I think we've given our listeners a lot to think about today. From the amazing properties of materials to the importance of using them responsibly, it's clear that materials are at the heart of everything we do.
And as engineers, we have the power to shape the future of materials and create a world that is both innovative and sustainable.
That's a great point to end on. Thank you so much for joining us on this deep dive into the world of materials.
It was my pleasure.
And to our listeners, thank you for tuning in to Engineering Out Loud. We hope you learned something new and are inspired to think differently about the materials that shape our world. Until next time, keep engineering out loud.